And 2 months into the pandemic, still having technology problems. Phone just shuts off, no reason. That's fun. Great, but I didn't really lose anything. So we got to know where these two are actually passing, or what their bounds are. So we know they cross at 0, 0, and 1, 1, because we've done a bunch with x and x squared. You can just set them equal to each other, in case you didn't know that. But we are looking to use kind of the shell method here. So yet again, we're spinning around the y-axis. So you either have to use disk and washers with respect to x, or the shell method. So let's try the shell. From 0 to 1, it would be 2 pi. And since we're spinning right around the axis, the radius is just going to be x, because as we get bigger, the radius goes from the center out, so it's whatever the x value is. The next thing we're going to have to look at here is what this height is going to be. So the height here is going to be, kind of like we did before, the top function minus the bottom function. So what's the top function here? That's the y equals x that we have, whereas our bottom is the y equals x squared. So we can apply that right here to what this f of x is. X minus x squared. And at this point we have the setup. Let's go and see what it looks like. Yet again, we can always pull this 2 pi out. And we're left with x squared minus x to the third dx. Integrating here. 1/3 x to the third minus 1/4 x to the fourth. We're from 0 to 1. 2 pi is still with everything. 1/3 minus 1/4. That's going to get us what? A 1/12. 2 pi over 12, which is just pi over 6. Okay. Let's do a quick recall if we had done it the other way. So if we had just kind of chopped things through here and said we wanted to do it like we did last week. Look at the disk method. So the disk method here is we're looking for the larger one minus the smaller one here. So that one, the larger radius here is going to be our x squared. X here, and the center was 0, we're spinning around. So, this is why I wrote this down. But since we're spinning around the y-axis, we need this in terms of y. That's the dyslexia. So I need this in terms of y. So although it's x squared here, really the way to think about that is that's the square root of x. And since it is y equals x here, it is just going to be y, right? Square root of y, sorry. So we need 0 to 1. It was with respect to y. And here, what's the formula? It's pi big R squared. The big radius here is y minus the little r squared. And the pi is being multiplied by both of them. Great. Sorry for that mistake. So yet again, it's pi big R squared minus little r squared. And we needed it in terms of y because we're spinning around the y-axis. Got it. So rewriting this nicely, it's going to be y minus y squared. This becomes there. We have 1/2 minus 1/3, which is in fact going to get us pi over 6. So great. They're the same number. If not, we would have broken math. We could have stopped here. School year would have been done and over with. Too bad. We got to keep going. Let's look at the next one. Okay. They're specifically asking us to use cylindrical shells here to find the volume of the solid obtained by rotating about the x-axis under the region of the curve here. I think this was actually the first volume question we did. So if we're spinning around the x-axis, we would normally think we're in respect to x. This is a nice solid disk question, and it can just go right from there. Real simple, real easy. showing you that shells can also work here is just kind of what the point of this question is. Since we are doing shells around the x-axis, this means we need it in terms of y. Okay, if we're going to set things up in terms of y here, we need to see kind of what this shell is even going to look like as we're going through this. So the shell here is going to be kind of a strange one to think about. Here to here. So the shell is sideways. Right? Normally our shell was going this way, but since kind of it's tilted, we have to look at our shells this way. And it's kind of going out. So yet again, I think easy enough to know what our bounds are here. If we're thinking from y from there to there, it is from 0 to 1. The 2 pi is still there. Now we need to think, what is our radius in terms of? And our radius is kind of growing as we go out. So the radius here should be just y at this point. We already said we're in terms of y. Now we need to decide what is the actual height of this function. And this is where it can be a little confusing to think about. As we're going out, the height is actually kind of getting smaller here. Right? Think in the very middle. Let's see, I'll draw this one in green. Notice this cylinder is taller than the green one. As we're going out, the height is actually getting smaller. It's kind of getting like a fatter cylinder that we're using here and a skinnier one in the center. However, this top piece is always staying the same. It's just here that's changing things. So we're thinking here, this is y equals 1, and this is y equals square root of x, which is really x equals y squared. So the setup here is going to be yet again kind of the top minus the bottom, but when we shift our perspective,